Next up is Jens Hoffrichter, and his talk is on DNSSEC at scale, enabling signing across 5,500 domains in the real world.
Hello, and thank you, Mareike, for the introduction. My name is Jens Hoffrichter, and I'm talking about DNSSEC in the real world today. We as DNS operators, we have asked us probably many times quietly, or probably many times not so quietly, why are these corporations not finally putting DNSSEC on their domains? I mean, it's not hard, is it? And today I'm going to show a little bit about a glimpse in a project like this going on. It's still going on, it's still not finished yet, where we have been enabled DNSSEC signing across 5,500 domains at a big customer of ours. A couple of words about me. I'm the managing director of P-Square. We are a small specialized consultancy specializing in DNS, SMTP, and DDI infrastructure. We work mainly in enterprise environments like automotive, manufacturing, banking, where we help customers doing all of these things. So the story about this is we are talking about a major automotive company which has a domain portfolio of about 5,500 DNS zones across a wide variety of TLDs. We are talking about, I think the last I checked, about 150 different TLDs where they have their DNS zones under. We had the authoritative DNS a couple of years ago already migrated to a cloud DNS provider, and we had DNSSEC enabled on exactly one of these zones. One we set up from scratch, and where DNSSEC was easy, but we didn't have DNSSEC on any one of the other zones. And the mission was to enable DNSSEC signing across the entire domain portfolio, because I personally think that that is a very good security practice to have DNSSEC on. So, but even getting the green light was not a particularly easy thing to get. I had multiple discussions at the customer where DNSSEC was seen as not particularly urgent. We are fine without it. The rest of our security stack is so good, we don't even need DNSSEC. And it was really hard transporting there to the people, even to architects who know a lot about network, that without DNSSEC you can't even make sure that customers especially are getting to your infrastructure, to your other security measures you are implementing. Is really one of the very, very basic building blocks you need to have in place for your infrastructure. The ultimate go for this project came then from some BSI requirements. The BSI is the German Federal Institute for Computer Security. They put out some new guidelines where especially DANE was required for all of email communication. DANE doesn't work without DNSSEC, and that was finally the trigger which gave us the go-ahead to do DNSSEC on the email domains, which was also seen as the most critical domains, but also that we can do then, it was discussed there that we are doing a rollout across the entire domain portfolio, but only do what doesn't cost money. For us as DNS operators, DNSSEC might be a no-brainer. It is not in the enterprise world. It's not for enterprise decision makers. It has a bad reputation, as we talked about in the last OARC, and is not seen as that much of a security gain. So, and how hard can it be? I mean, I've done it myself for my personal domains. Enable DNSSEC signing on the cloud DNS provider. It is basically a check mark where we are hosting our DNS, retrieve the DS record, submit it to the registrar who puts it in the registry, verify that it's working, all good. Now repeat that 5,500 times. The first surprise we had was that at the largest domain registrar this customer was using, we couldn't even submit DS records there. They didn't have the possibility for domains where DNSSEC, for TLDs where DNSSEC was definitely possible, for example for .no, where I personally had enabled DNSSEC a bit before. They didn't accept DS records at all because there is, I think on the NO side, it was that the NO registry has very specific requirements about how the API is being to be used. The registrar didn't want to comply with that, so they didn't have any path to enable DNSSEC for .no in their API at all, and they said manually, we are not going to do this. And maybe even smaller CCTLDs might not even have an API for this, or if there are intermediaries involved. I'm going to talk about that a little bit later. So for around 200 domains, which were at our main domain registrar, we had no path to DNSSEC at all. So these domains needed to be migrated to a secondary registrar we were using already for the more complicated things, for things which are not as easy, which are not automated. But that was also an additional cost because every domain transfer costs some money, because not every TLD supports the extension of the runtime, so everything there costs money. And then as I said, about the chain of intermediaries, that was something we hadn't quite expected in the beginning, that even where it is possible for CCTLDs to enable DNSSEC, this might not be a straightforward process. I'm using here China as an example because the Chinese registry seems to be particularly picky who they let access their interface, so we needed to go through an intermediary. So it's not really a registrar here in this case, in the purest sense of the word, it's more a domain service provider. And then there is no API, nothing where we can communicate these DS records automatically, but it will be just put in an email, said here, please enable DNSSEC for this and this domain. There might be typos in there, there might be copy and paste errors in there. It is an error-prone process because it is manual, and unfortunately errors did happen in this, which is not surprising, honestly. Then another thing we had with time zones, we sent out an update for please enable DNSSEC on this Brazilian domain. We sent that out to our domain service provider. They forwarded that email to their intermediary. 3 hours, 4 hours, 5 hours later, it was already after business hours for us. They put it in wrongly. The whole domain was down. The Brazilian subsidiary couldn't work. But for us, we didn't notice it because we are working German business hours. That was after business hours for us. It wasn't communicated to us until the next day, and it was an extended downtime before we could fix this. If it had done the minute or in the half hour after we had sent it there over, we could have detected it and fixed it immediately. But this was a little bit with time zone things where we simply didn't have, where simply that bit us in the behind. So the lesson we took out of there and we learned while doing this project is plan your DNSSEC enablement for the time zones around the business hours of every party involved, especially for important domain production domains, email domains, and especially if it is something important we learned and intermediaries are involved in this, make a call with all involved so it can be done live. You put it in, you can do the validation immediately, and you don't run into this problem with extended downtimes here. The next thing, which, if you think about it, is clear, but I didn't think about it in the beginning, that there are TTLs involved here, which you simply don't control. We are typically running with fairly low TTL, so like 300 or 600 seconds for our DNS records, so any rollback can happen pretty quickly. But you don't control the TTLs of the DS records because those are controlled by the TLD. And they might be putting in fairly long TTLs. We have seen some TLDs where the DS TTLs are set to a day. So if mistakes happen there, it might take a day or even two, or if it is really unfortunate, it happens on a Friday evening. I don't propose doing changes like this on a Friday evening, by the way. It might really take an extended downtime until it is flushed out everywhere, until it is out of the caches everywhere, And this might just lead to days of impact if you're really, really unlucky in these things. So think about that, make the things, try to make them right. Of course, we're always trying that. But if you're doing these things, be on top of them, roll them back as quickly as you can so that these TTLs might not impact you, and maybe check before what the TTL for these DS records are. Then there was a little bit, I have to admit, this DNSSEC enablement was not done by the most experienced persons on the team, because this is mainly communication things. So for our big registrar, where all the automatic stuff is already happening, they needed the DNS key to enable DNSSEC for these zones. So we started out sending out the DNS key to all the other providers. They, of course, need the DS record for this, which is a hash, which includes the zone name as well. The DNS key might, this is, I changed it later, the DNS key might be the same for every zone. It is for us at our DNS provider. They use the same signing key for every zone, but the DS record is different for every zone. And we were just sending out the DNS key to registrars. They needed to, if they just needed to put in the DS record into the zones, there is another manual step involved. Every manual step is more error prone. So because they needed to do them hashing themselves, and this is just the thing, don't assume what works as one registrar works at every registrar. That is a very diverse ecosystem of companies who work all a little bit differently. Just verify what all these people need to work correctly with the DNS data. This is something which was particularly painful in the migration. We had an outage on the .cloud domain, which hosts all the delegation for all the AWS domains at this customer. That means there was a lot of production things involved when this went down. And this was actually because of an ambiguous field label in an interface we didn't even see. That was our registrar needed to put in the DS record. The field was labeled something we found out in the when we did the root cause analysis of this. It was something labeled like DNSSEC key. They put in the DNS key record for this, and it took down the complete cloud domain, which was very painful. We had, fortunately, resolved this within half an hour or so. But the worst thing about this was the employee from the registrar later said, "Oh yeah, I had calculated this DS key. This was different than the other DS key I calculated. Somehow this couldn't be, right?" He wasn't even aware that the DS record, the DS key, includes a hashing of the zone name for it, for which it is generated. And these are the people we have to rely on to get the DNSSEC right. This was, as I said, a particularly painful example what happened during this migration. Another thing which we hadn't really planned for is the registries wake up. Putting in DS records in a zone is counted as a zone update. And so you suddenly need to comply with all the current regulations for the zone. If a zone has been registered 5, 10, 15 years ago, there might have been a completely different set of regulations surrounding this domain. What you need to provide in terms of documentation for registering this domain, what kind of contacts are allowed for an owner C, for an admin C, whatever. And that might have changed, and you might have to suddenly update all these records and all these things. And especially in a corporate environment, it is not particularly easy getting a current company registry for a multi-billion-dollar enterprise to upload this. This might take days or weeks to get this done, and this might block out your DNSSEC rollout in ways you simply couldn't predict before, because on the zone we have registered 10 years ago. I don't keep track of all the regulation changes across all the TLDs, I have to admit. So it really is a thing like, yeah, suddenly the TLD has you on the line and says, oh yeah, well, we are having you. You have to update these things, and this has been blocking us on quite a number of domains to get this all right. Then there are also not an insignificant number of TLDs who charge for each update to the zone, to the domain. Japan is, for example, a very, or at least as far as I know, I think they charge around, for our registrar, I think around 20 euros per domain update. If you have 100, 150, 200 domains registered there, suddenly you are talking about cost, because the submission of a DS record suddenly costs money to do that. And additionally, it's another thing, DNSSEC adds more resource records into your zone, and if your DNS provider charges you by the resource record you have, this might also incur additional costs you might not have expected. We have a couple of TLDs where we simply can't do DNSSEC. United Arab Emirates simply doesn't offer DNSSEC at all. We have another TLD, that's the Korean TLD, where they require algorithm 8 for generation of the DS key. Our cloud provider exclusively signs with algorithm 13. There's simply no compatibility between these two. One of them needs to change to get it to work. I doubt that the cloud DNS provider will go back to an older algorithm, so I really hope Korea updates their things. So this was the strategy we finally settled on to get this project running. We started with the email domains because there is a very, very high compliance argument to get this done, because email is still a very valuable communication protocol, and there is a very high security value to get this done and to get DANE enabled, which really makes TLS a lot stronger there. We are grouping our domains by registrar and TLD to get all of these intermediary overhead a bit reduced. Of course, where we can do it by API, we are doing it by API. We are prioritizing that. Time zones is another thing we really take care of now. And if you have some exotic TLDs where every update costs money, budget that. Try to get the budget for it, but doesn't let us stop here. We didn't let us stop the DNSSEC project at all. The takeaways for this: enabling DNSSEC is no longer a DNS problem. The DNS problem, the DNS side of it has been solved years ago. It is now a registrar logistics problem. Because you are talking to so many registrars, registries, you don't know how deep the chain goes, how many different people are between you and the registry. It might be none, might be 3, 4, 5. We have seen quite a bit there. The supply chain there is really deep and really messy for these things. Human error, if human copy and paste is involved, is inevitable. Plan for rollbacks there. Know your constraints, what costs money, if you have limitations around resource records, for example, and automate verification, because you cannot automate 5,500 domains. And a thing there is train your people on the verification tools you are having. Use the great verification tools from VeriSign, the DNSSEC lab, or the DNS-OARC from OARC. Those are great tools to do DNSSEC validation if everything you have done works. Those are great tools, and your people should really know how to use them. And the organizational buy-in might be the most difficult at all. It might not be a technical discussion you're having, it might be a political discussion you're having for this. So yeah, thank you very much. If anyone wants to reach out later, you're more than welcome, or if there are any questions right now.
Okay, we have a little bit over 5 minutes for questions and answers, so please do come up to the mic, and please do list your name and your affiliation. Thank you.
Hello, Matthijs Mekking, IC. Thank you for this presentation, because one important aspect what you mentioned is that technical, the DNSSEC is basically solved, but you show that maybe on the process side we might have some work to do. So
Yes.
Thanks for the takeaways there. You focused a lot on things that can go wrong, but you managed to sign those 5,000 zones?
I'm so sorry, that was not. So the project is unfortunately not finished yet. We are after a year, about halfway through. So we have about 2,700 zones signed, but which is mainly now a resource limitation. On the resource records we're having, there are some internal things where we're using some special features from our cloud DNS provider, which we cannot use anymore with DNSSEC, which reduced the number of resource records we needed to license. So it is now again a budget discussion we are having internally. And that's right now, especially in the automotive industry, very, very difficult.
Okay, well, anyway, keep up the good work. And one final remark, you mentioned on the Korea domain that it uses a different algorithm. I don't think that needs to be an issue. You can sign your zones with different algorithms as long as the validator understands those algorithms. It should be able to verify it. But I'm happy to be corrected here. That's my understanding.
That was something which was communicated to the team by me, that was a stopper for Korea. I honestly have not verified that myself, but I'm more than happy to take a look at that. Thank you.
Thanks again.
Hi, this is Peter Thomason. It sounds like a terrible experience.
No, it is. Well, honestly, to get this presentation, so this was done by my team, the DNSSEC, and I got the person who was mainly responsible for that. I got into a team session and I told her, you are allowed to rant now, to tell me about your experience, and I recorded that and made this presentation about that.
So you said improving DS provisioning is now mainly a registrar sort of development thing.
Yeah.
I wanted to point out that there is automation available that some registries already do, like .se and .cz and all of that, and they skip the registrar. So
yes.
A conclusion could be that is a registrar/registry thing. And I think many registries are more versatile around DNS issues than the registrars are. So it seems like maybe that's that.
But we looked into the CDS thing. I think about right now 6 registries maybe supported, maybe 8 or something like that. It is not a high number for 150 TLDs, and those are usually the ones which we can automate anyway. It is more like the really, if you have ever tried to update a zone in Saudi Arabia, I cannot recommend that experience.
Yeah. So my questions really are. For the ones who supported, did you use that automation? And the other question is, did you have any registrars that rejected provisioning DS records for GTLDs?
So no, we did not use that. We have 2 registrars we are using because we are bound by procurement processes, of course, by the automotive company. We had registrars who I said rejected DS records for .no, for example, and we needed to transfer those domains over to another registrar who could do that then. Right,
but did you have that for GTLDs too, or just for CCTLDs?
I am not sure.
Okay.
But I think it was just for the CCTLDs. Thank you.
Ralfi Bakama, thanks a lot for doing the hard work on the DNSSEC domain and also reporting on it. And I see it, I mean, have worked in operational. I see what you talk as a kind of like maybe a war story, and not that is kind of like, yeah, you don't want to do it. So thanks a lot for doing this. Now, what I see is that most of the problems are in the registrar space. Yeah. So would you be willing to give that talk maybe in an ICANN context or where there are more registrar? Because these, I mean, we have some here, but this is more kind of DNS operation. So I would really like to, if you could take that into other forms.
Absolutely, absolutely, no problem at all. Yeah. And of course, I focused a lot about the things which didn't work, because that's the interesting thing about the 1,500 domains where it just was enabled and it worked flawlessly on the first try. Of course, we don't talk about this on this level. Yeah.
Yeah, thank you very much. And, you know, the devil's always in the details, right?